Okay, I did write some other things on this page that would be worth looking at. We don't need to know anything about tangent. Standard form of a trig function, you've got a sine b of x, where a is 1 and b is 1. The length of one rotation or cycle is the period. The amplitude is the height, and I did not mention that it's always positive. The height of something is always positive, so you're always going to go from the middle to the tippy top, so it's positive. A is 1, so the amplitude is 1. Sine always starts at 0. That's really important to note, and y equals sine x is the parent function. So if we look at cosine always starts at, for the parent function, it always starts at 1, but that's your a value. So if we change this from an a value of 1, if we change the radius to 20, cosine would start at 20. A is 1, so the amplitude is 1, but if a was 20, the amplitude would be 20. Both of these parent functions, to go around the circle one time, is a period of 2 pi or 360. And b is the frequency, the number of cycles within one parent cycle. Period is simply the length of one cycle. So if there's anything on here that you want to write down, I wrote it a little bit differently, you can. All right, a better look at amplitude. So now we're going to page 25. And I promise we're almost done learning about the characteristics of these functions, and then you'll start graphing them before we learn about shifting them left and right and up and down, h and k. So better look at amplitude. I'm going to zoom into this. I think you get the idea that this is the radius of a circle. So if we look at the parent function, which is this one right here, the radius is equal to 1. So the amplitude is equal to 1, a height of 1. And since this is sine, it goes 0 to a maximum height of between 0 and 2. So 1, 0, -1, back to 0. The next line shows y equals 5 sine x. So a is now 5, so the amplitude equals 5, which means it's a circle with a radius of 5. So we still start at 0 for sine, but now we're going 0 to 5, 0, then we go to -5, and back to 0. So I should probably write in that we went to 1 and then to -1. And on the last one, r of x equals 10 sine x. So the amplitude is equal to whatever the positive a value is, so 10, and that means it's a circle with a radius of 10. In that case, we go from 0 to 10, 0, down to -10, back to 0. And again, the amplitude is, we'll do for this one, the height from the midline. The midline would be right smack in the middle of the graph to the highest point. That would be your height, drawn perpendicular to the midline. You draw it straight up and down. Like if you go to measure your height at the doctor's office, the doctor says, stand straight up, stand up tall. You always want to stand perpendicular to the ground when you measure height, and that would be a height of 10. So the amplitude is 10. The distance from the midline to the maximum value. The minimum value would be -10. So technically the amplitude or the height from the lowest value to the midline is also 10. All right, what about with cosine? So same thing. We start with the parent function. The amplitude here would equal 1. The big difference here is that our graph now starts at 1. These all started at 0. So we go 1, 0, -1, 0, and then back to 1. For g of x, the amplitude is 5, and with cosine that means you start at 5, Then you go 0, -5, 0, back to 5. And when your amplitude or A value is 10, your amplitude is 10, and we start at 10. 10 to 0 to -10, back to 0, and then back to -10. I mean to 10, not -10. Oh. Okay. Better look at period. So this is what I was showing you before. When you have a frequency and then you change the frequency, you change your B value, it changes the period of the function. So better look at period. In this particular problem, your B value equals 1. 10 cosine 1 of theta or x. So your amplitude is still 10, so this is going 10, 0, -10, 0, back to 10, but B is 1. So that means you have one cycle or one complete curve from 0 to 2 pi, or from 0 to 360 degrees. So one cycle. We start at 0, we end at 2 pi. We got to do one complete cosine curve, so we go 10, 0, -10, 0, back to where we started, done. In this graph, we've changed B to 3. All right, so that means we still have an amplitude of 10. We're still going to be using those main points on the x and y axis as 10, 0, -10, 0, 10, 0, -10, 0, repeating that, but we got to do it 3 times around before we get to 2 pi. So the way we're going to do this is first figure out the period, because I want to be able to graph that. That last one was kind of difficult for me because we couldn't break the graph into thirds neatly. But you calculate the period, and we always do that by calculating 2 pi, because that's the length of one cycle normally, and we divide it by whatever B is. So in this case, the period or the length of one cycle goes from 2 to 2 pi over 3. So that's where the end of the first cycle has to be. That's the length of one cycle, period, the length of one cycle. So if this were degrees, we don't usually do period in degrees, but it would be 360 degrees divided by 3 is 120 degrees. And that's equivalent to 2 pi over 3 radians. Okay, so we got to have 3 cycles from 0 to 2 pi. So figuring out where the first cycle ends is pretty helpful. So it ends at 2 pi over 3. That means my second cycle is going to end, I'm going to times that by 2. I'm going to double that. So this is the end of the second cycle. That's going to be 4 pi over 3. And then the end of my third cycle is right here, which is 6 pi over 3. And that simplifies to 2 pi. So I'm going to go around, and I need to basically show those x, y axes, those important points. 1, 2, 3, 4, and back to 0. So really, I'm showing the 4 quadrants. I'm showing my starting point right here, but then I have to go 1, 2, 3, 4. And then I go around again. 1, 2, 3, 4, and then I go around again. So I need to split this into 12 sections from 0 to 2 pi. I don't know if that makes sense, but you start here, and then you go around the circle. So first point, second point, third point, fourth point. That's your one trip around the circle. 5, 6, 7, 8 would be your second time around, and then 9, 10, 11, 12. And that's 3 trips around the circle. So this is my starting point, but I got to split this into fourths. I have to say, okay, here's 2 pi over 3. So halfway around the circle is going to be half of 2 pi over 3, which is at pi over 3. And then if I split those in half again, I've got a spot for all 4 of my points. So from 2 pi over 3 to 4 pi over 3, I split that in half and then in half again. And I'd have room for all 4 of those. And then from 2 pi to 4 pi over 3, I split that in half and then in half again, and that would give me room for all 4 points. So we're going to do a lot of splitting these sections in half and then in half again. And we do that so that we can get 4 even sections to graph these 4 points around the circle. So starting at 10, I'm going to plot those 4 points going around the circle once. We go 0, negative 10, 0, back to 10. And then around again. 0, negative 10, 0, back to 10. And then 0, negative 10, 0, back to 10. And that would be 3 complete cycles. So that's a frequency of 3 complete curves from 0 to 2 pi, but the length of one cycle is going to always be where the first cycle ends. So the period is always going to be where the first cycle ends. B equals 3 is the total number of cycles. So my first cycle, my first curve ends here. That's B equals 1, 2, and 3. So 3 total curves. If you're having trouble understanding that, let me know. But we're going to start making your own graphs, and hopefully then you'll really get a feel for how to do this. We're going to summarize all this on page 26. So if you're not understanding it or you're having a little trouble, this is going to help you, I hope. Parent function. So we have our basic parent function, which has an a value of 1 and a b value of 1. So y equals sine of theta, or you could write it as y equals sine of x, or f of theta equals sine of theta. Those mean the same thing. This one, y equals cosine of x, or f of theta equals cosine of theta. And we are not going to do anything with tangents, so you could basically just cross out all of this. Okay, for a sine parent function, the y-intercept is at 0. The amplitude or the height, because a is equal to 1, our amplitude is 1. And b is also equal to 1, so the period is just 2 pi. So the length of one cycle of the parent function is 2 pi. It's 360 degrees, but really any question you're asked about period is going to be in radians. For cosine, the y-intercept for cosine, when a is 1, and I'm going to write that, I guess I'll write that here. Y-intercept, if a is 1, for sine it's still at 0, but if a is 1, for cosine, you're going to start at 1 for the parent function. The amplitude is also 1. It's still the a value. And the period is still the length of one cycle of cosine, which is 2 pi, or 360 degrees. But then when we put the a and b values in, that changes things. So we have now an a and a b value. And now we'll summarize how that changes the information that you're looking at. Okay. Your y-intercept for sine is always at 0. From that point, normally on the parent function, you would go from 0 to 1, and then 0, negative 1, and then back to 0. But if you change your a value, you're not going to go from 0 to 1. You're going to go from 0 to whatever the height of your radius is. So you go to whatever your a value is. If your a value is positive, you're going to go up. If your a value is negative, you're going to go down. So if you think about any time you had a negative a value in any function, that was a reflection. So what that means is if sine has, don't write this down, but if you're graphing sine and you start at 0 and your a value is positive, you're going to go up. And if you're graphing and you start at 0 and your A value is negative, you're going to go down first. So if you go up, your curve is going to look like that. If you go down first, your curve is just going to be reflected. So it is possible to have a negative A value. It means that you're going around the circle in the opposite direction. Okay. Your amplitude, if you do have a negative A value, your amplitude is going to be the absolute value of whatever A is. So amplitude is always positive because it means height. Even really short people don't have negative height. So height, amplitude, it's always positive. So it's the absolute value of whatever A is. All right, the number of reps in the parent interval. That means frequency, the number of repetitions. So the speed, the number of cycles. So this is called frequency. And that is your B value. And the period, we said, is the length of one cycle. So it's the end of the first curve if you have multiple curves. So the length of one cycle for the parent function is 2 pi. But for any other function, it's 2 pi divided by B. Technically, it's also 360 degrees divided by B. But again, we're usually going to be looking at it in radians. So if you had a B value of 6, then in degrees, it's easy. 360 divided by 6 is 60 degrees. So each cycle would be 60 degrees, and you'd have 6 of them from 0 to 360. In terms of radians, it'd be 2 pi over 6, and that would simplify to 1 pi over 3. So pi over 3, which is equivalent to 60 degrees. Now let's look at how this is a little bit different when you have cosine, because cosine does not start at 0. So where would a cosine curve start if you change your A value? Well, it starts at your A value, at whatever A is, not the absolute value of it. If A is positive 10, you start at 10. If A is negative 10, you'd start at negative 10. So I'll sketch the difference here also. And again, you don't have to write these down. But if A is positive, you're going to start at A, and then your next point at 90 degrees is going to be, you're going to go to 0. So sine goes from 0 to A, cosine goes from A to 0. So if A is 10, for cosine, you'd go 10, and then your next point would be 0, and then negative 10, and like that. But if A equals negative 10, it's going to be the reflection. So you're going to start down here, and then go to 0, and then up, and then down. So this is essentially the reflection of this graph. The amplitude, though, is always positive. So if A was 10, the height is 10. It's always the height from the midline, the middle of the graph, from 0 to the highest point, which would be 10. And even if A is negative, you go from the midline to the highest point, which would be over here now, but it'd still be 10. So both of these, even though A is 10 and negative 10, both of them have an amplitude of 10. So again, the amplitude is the absolute value of A. The number of reps in the parent interval is still going to be whatever B is, and the length of one cycle is still going to be the period, which is always 2 pi over B or 360 degrees over B. So we are going to take a look at how to graph these, and then I'm done. So we are almost done. Okay. Determine the amplitude, number of cycles from 0 to 2 pi So we are at the bottom of the page. Let me just scroll down. Determine the amplitude, the number of cycles from 0 to 2 pi, and the period of each function. And then we're going to draw graphs. So determine the amplitude, that's your absolute value of A. The number of cycles from 0 to 2 pi is your frequency, that's B. And the period of each is going to be 2 pi divided by B. And then we're going to graph them. So first I'll help you with number 1. A is 7 and B is 2. Your amplitude is going to be the absolute value of 7, which is just 7. The number of cycles or frequency is equal to 2. And the period is equal to 2 pi divided by the B value, which is 2. So the period in this case is pi radians. And again, if you think about it in degrees, it would be 360 degrees divided by 2, and that would be 180 degrees. And pi radians is equivalent to 180 degrees. So in this graph, I'm going to graph this one and then we'll go to number 2. So in this particular graph, these graphs you're given kind of a blank XY axis, and you're given that for a reason, so that you could split it up into whatever your frequency is. So here we have to show 2 cycles from 0 to 360. If we have to show 3, we're going to need to break it up differently. So we're going to go from, always start at 0, radians. And we're going to show this graph from 0. We'll go to 2 pi. So we put 2 pi down here at the end. And I want to show an A value of 7, a height of 7. So on my y-axis, I've got to go from 0 to positive 7 and 0 to negative 7. So whatever my A is, I'm going to put the positive and negative here, and that's the highest I need this to go. It's never going to go above or below that until we learn how to shift the graphs up and down. And then we have a frequency of 2. So my first cycle is going to end at pi, which is halfway between 0 and 2 pi. So you want to just kind of eyeball where halfway is. That's about halfway. So we'll put a pi there. Then I've got 2. This is the tricky part. I've got to show 2 cycles, and each of them has to be 1 pi radian long. So I've got to plot those 4 points at 90 degrees and 180 and 270 and we got to plot those 4 points as we go around the circle. So we've got to split each of these sections into fourths, because again, as I go around the circle, I want to show my key points. Starting here, that would be this point 1, 2, 3, 4, but I got to go around a second time because B is 2. So I got to go 5, 6, 7, 8. So I'm going to have to plot 8 points. So I got to split this. It's already split in half. Now I got to split each half into fourths. So to do that, I'm going to split this first half in half again. And that's only going to give me enough to plot 2 points in the first rotation. So now I got to split each of these in half again. So when I split things into fourths, I want to split it in half and in half again, because it makes it look a little bit better than if you try to split it into fourths. Like if I just try to go 1, 2, 3, and then that would be the fourth one. They're not always as accurate. Try to eyeball it and split it in half, and then go in half again. All right, so there you've got room to draw 8 points as you go around the the circle. It's not a unit circle because the radius on the circle would be 7. All right, this is cosine. So where do we start? Do we start at 0 or do we start at 7? And in this graph, we're starting at the A value. So here's where we're going to go. Start at 7, then our next point after 90 degrees is at 0. So 7 to 0 to negative 7 to 0, back to 7, and then we go around again. So 0, -7, back to 0, and then back to 7. So we end where we started. And what this should look like when you're done is 2 complete cosine curves. So the cosine curve starts here, and you're not zigzagging, you're trying to kind of make a wave. I think of this as like a little piece of a parabola, and like that would be like a parabola top, and then this one would go down. Or you could think of them as like quarter circles. Essentially, that's what it is a quarter of a circle. This is a quarter, this is a quarter, this is a quarter. If we move these pieces and put them all together, it would make one circle. Anyway, so we got 2 complete cycles. This is the end of the first cycle. This is the end of the second cycle. So the length of each cycle, the first cycle ends at pi. All right, so I hope that all is starting to make sense. So we're going to start the next graph. Y equals -8 sine 3 of x. In this graph, A is -8, B equals 3. So we're asked to find the amplitude, which is the absolute value of A, which is 8. So it's a height of 8 from the midline to the highest point. Our frequency is our B value, so we have to have a total of 3 curves. And the length of each curve is going to be 2 pi divided by B. So 2 pi over 3, that doesn't simplify, so I've got to end my first curve at 2 pi over 3. If you want to think about it, 360 divided by 3, that's 120 degrees. And 2 pi over 3 radians is equal to 120 degrees. All right, so we set the graph up. We always start at 0. This graph, again, we'll go to 2 pi. Sometimes the graph, they'll tell you exactly where to go to, like go from 0 to 4 pi or 0 to 3 pi. So they didn't tell us here, so we're just going to go 0 to 2 pi. All right, the maximum height that we need and the minimum height, since A is -8 and our amplitude is 8, this whole entire graph is going to exist between -8 and 8. So it has a range of -8 to 8. And then I need to show 3 cycles. So splitting this in thirds is a little harder than splitting it into halves, but I need 3 cycles. So I'm going to have to split this graph into thirds and then have my 4 main points for each rotation. So you might split it into thirds and then be like, that doesn't look right. So you want to eyeball it and try and get it to look pretty good. I feel like that looks pretty good. Maybe this is a little bit bigger than that. So if you go to draw thirds and it looks really bad, then definitely do it again. I'm going to show you what I mean by really bad and good. Okay, so if you had plotted this and you said, okay, I'm going to split this into thirds, and you said, okay, here and here. Well, those 3 sections are totally not even. That doesn't look good at all. So when you do it, you want it to look good. So do your best to split it into 3 equal sections, and you do that by drawing just 2 more lines. So I think about here and here. It's still not perfect. I feel like the first one's a little smaller, but I'm going to go with it. So where would those sections end? Well, if each section is 2 pi over 3, this right here would be 2 pi over 3. Double that would be 4 pi over 3. And this again would be, we keep getting the same one, 6 pi over 3, which simplifies to 2 pi. So that should work. Now I got to split each of these into 4 sections. I do that by cutting it in half twice. So anytime, you can write this down up at the top. When you're graphing these, you want to cut each section in half twice so that you have 4 equal sections. So cut this in half would be about there. Cut it in half again, and cut this in half again. So that should be about 4 equal sections. So that's going to give me the points I need as I go around the circle. I'm going to get back to where I started. Then I need 4 sections again. So cut this in half, and in half, and then go to your last section and do the same thing. So you could, if you wanted to know how many sections you need total, you could take your B value and multiply it by 4, 8 sections on your graph. But again, you want to do it by cutting it in half and half and half. So that's 1, 2, 3, 4, 5, 6, 7, 8. For this one, 3 times 4, you're going to need 12 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so let's get to graphing. For sine, we always start at 0. So there's my first point. It's a sine graph. And then we go to our A value. So for every sine we've done so far, we've gone up. But this one says an A value of -8. So this one's going to start by going down. 0 to -8, back to 0, then up to 8, and then back to 0. Then repeat. -8, back to 0, up to 8, and back to 0, and then repeat. -8, back to 0, up to 8, back to 0. And then you start sketching in your curve. Again, the easiest way to graph this so it looks neat is think that you're drawing kind of like quarter circles, or pretend that this part right here, pretend this is the bottom of a parabola. It's almost easier to start at the bottom and sketch upward. And then you think of this as the top of a parabola and arc, like kind of curve it downward. So it's easier than trying to just draw one long, wavy, neat thing, because a lot of times your graphs will come out sloppy if you just try to do it all in one stroke. All right, so that's pretty much the graph for that one. Okay, I think I'm going to do this one with you also. I'll probably just do all 4 because they're kind of hard. All right, in this one, your A value is 1/4. B equals 6. Amplitude is the absolute value of a fourth, which is 1/4. Frequency equals 6. And period is 2 pi divided by 6, which is pi over 3. Again, in degrees, that's 360 divided by 6, so that would be 60 degrees for each one. But we're going to do this in radians. So we're going to go from 0 to 2 pi. I've got to show 6 cycles, so I'm going to have a total of 24 sections in this graph. That's a lot, so we got to be neat. So don't think that you could just draw, so 24 sections, we're going to need 23 little hash marks to split this up. Don't try to freehand that and just do it in one shot and think they're going to be even. We're going to just keep cutting in half, cutting in half, cutting in half until we have 23 hash marks. So before I do that, I'm going to put in my amplitude. So it's a height of 1/4. The only thing different here is I have positive 1/4 and negative 1/4. Doesn't matter that it's a fraction. My range is going to go from -1/4 to 1/4. All right, so I'm going to cut this in half. I'm going to start with that. And cut this in half again. I'm going to stick to just getting my first section set up. Oh, no, I'm not. I'm going to cut this in half again also. All right, so that right there would be enough for me to show 4 curves. Actually, this isn't going to work. If I cut this in half again, I won't have 6. I would have enough for 8. So, got to scratch my plan. That cutting it in half at the first time isn't going to work. I'm going to have to cut this into thirds and then cut it in half. So see, sometimes it requires a little bit of thinking. Okay, so I'm going to do what I did up here and cut it into thirds, because that would give me enough for three graphs, three complete curves, and now I'll cut each of these in half, and that would give me 6. So the way I did it before, cutting it into half and a half again and half again, would have given me 8. So I want 6 total. So cut it into thirds and then in half. So if I cut each of these in half, that's going to give me the end of each of my 6 cycles. So I hope that makes sense. So my first cycle is going to be drawn, whoop, it's going to end there. Second one, third one, fourth one, fifth one, sixth one. So now to get my points accurate, I cut each of these into the 4 sections that I need, cut it in half and in half. All right, so now I have all the marks that I need. I think it is important to label just the end of each period. So I'll draw these a little bit thicker and taller just to make them stand out. And then we're going to label them. So each of these sections is pi over 3 radians. So this would be 1, we could write it out as 1 pi over 3 radians. This would be 2 pi over 3. This one would be 3 pi over 3, which hopefully you realize is going to simplify to pi. This would be 4 pi over 3. This one would end at 5 pi over 3. And then again, like we saw before, this is 6 pi over 3, but it simplifies to 2 pi. So I wouldn't really write 6 pi over 3. My goodness, this thing is going so slow. And I also wouldn't really write 3 pi over 3. I also wouldn't really write 1 pi over 3. I would just write pi over 3. But I want you to understand how I'm getting these values. So this was 3 pi over 3, which really simplifies to pi. And the 6 pi over 3 is 2 pi. So that's split up, and that's the end of each curve. And now I put in my points. So cosine. Cosine starts at 0? No. Cosine doesn't start at 0. It starts at A. So our A value is at 1/4. So we're going to start at 1/4. And then we go to 0, negative 1/4, 0, back to 1/4. Then you repeat. And what you're going to notice is your lines up here probably aren't going to line up. If you wanted to kind of sketch in a line across here so that you know where you're kind of going, we could always erase that later. So 1/4, 0, negative 1/4, 0. 1/4, 0, negative 1/4, 0. And repeat. And then neatly sketch the curve. And like I said, I can now go and just kind of clean things up a little bit and get rid of these dotted lines because they're not significant. And normally if we draw in a dotted line here, it's kind of like when we draw in an asymptote. The dotted line isn't really part of our graph. It's just showing us what's significant. So a lot of times if we do draw in a dotted line in this graph, it would be at the midline. I don't know why this is working so slow. I just want to erase. Sorry, I should just leave it messy. It won't let me erase. Goodness gracious, it's going to take me 10 minutes just to erase the dotted line. Okay, so there's the graph. F of theta, number 4, equals negative sine pi of theta. So this one I have to show you because your B value is given to you in terms of pi. And that's a little bit different, but it still works the same way. So your A value is negative 1. Your B value is pi. So your amplitude is the absolute value of negative 1, which is 1. Your your frequency, is just your B value, which in this case is pi. So that basically means you have pi curves in the length of one parent function. So pi is really 3.14. So we're going to have 3.14 total curves from 0 to 2 pi. It's going to look a little bit different, but that's what it means. Period is 2 pi divided by b, which is pi. The pi's cancel, and the period is 2. So it's just 2. There's no pi. It's just 2, like a regular number 2. So what will that look like on a graph? So we start at 0, and instead of going to end at 2 pi, we could just end at 2 and show one cycle, but I think we're going to show more than that. Why don't we show, since it doesn't say here, we're going to end at 6, just so you have a good understanding of what's happening here. So from 0 to 2 pi, from 0 to 2, we're going to have one cycle. So if we go to 6, that means I'm going to split this up into thirds. So split it into thirds again. And the first cycle will end at 2, the second cycle will end at 4, and the third cycle will end at 6. My amplitude is negative 1, so my highest point is going to be positive 1, and my lowest point is going to be negative 1. And the same idea, the end of the first cycle is going to be at a whole number 2, but I've got to show all 4 of those key points. So split this up into fourths. That wasn't very good. I didn't do a good job. That's what's so good about being able to erase these points. So I cut this in half, and I didn't do a very good job. So I'm going to cut this in half and then cut it in half again. Maybe that's a little better. Cut it in half and in half. Cut this in half again. Cut it in half again. So now what we're going to do is sketch one complete cycle that's going to end at the whole number 2. Where do we start? So this is sine. Sine starts always at 0. And we go to, not positive 1 this time, our A value is negative 1. So I'm going to go 0 to negative 1. And then back to 0 to positive 1. And back to 0. So there's one complete sine curve. And I'm going to repeat that 3 times. So there's my first curve. Now, if they didn't tell us that we needed to show go to 6 or show 3 cycles or whatever. We could have just drawn one curve and been done, but I felt like we should just draw more so we understand. Okay, so there's 3 complete curves. The very first cycle ended at 2, and that's that. So on the next page, 27, you're going to graph all 4 of those graphs, and it tells you graph from 0 to 2 pi. The second one says sketch 2 complete cycles. So in that one, you're just going to sketch 2 complete cycles. So wherever it ends, it ends. And then that'll be classwork to do all 4 of those graphs. And then your homework is going to be, you're going to skip page 28. We're not going to do anything with tangent. And you're going to go to page 29, and you're going to just do on page 29. So let me take a look at that on here. I think maybe this is page 29. No. I got to find it. Yeah, that's it. So on page 29, and it's fine, if you just got a sneak peek of the answers. For homework, you're going to skip any of the problems that say tangent. So you're in this section, you're going to do just numbers 1 through 8. And then these are all sine and cosine curves. So you're going to do this whole section. And then on the next section, you are going to just do numbers 14 through 18. You'll get to skip 19 and 20 because those are tangent graphs. Now, if you look, the graphs are given to you in degrees, and it's missing negative 360 degrees. And some of these graphs are going to require you, or all of them are going to, they're asking you to go from negative 2 pi to positive 2 pi. So you're going to graph from really negative 360 to positive 360. It's just that these are not written in radians. So there's 0 and there's positive 2 pi is at 360. So you'll then go on to the next page. Page 30 is where you'll show your work for the rest of those graphs. All right. Yeah. So you just go on to page 30 and you'll get to skip these 2. Okay, so for your classwork, like I said, you're going to complete the 4 graphs on your own that are on page 27. And you can push play when you're done doing that, and I will show you those 4 graphs. All right, so here is the first graph on page 27. And if you need any help, let me know. This is number 2, number 3, and number 4. And if you want, you can come back and take a look at the answers to the homework from home. So here are the homework answers. And here's the graph for number 14 on this page. And then page 30. I'll just scroll down and you can pause it if you need to. Well, you only need to see up to 18. So 15, 16, 1718. All right. That's it for today.